The 64 string splitter. So there is a string splitter with the following two special properties. So the printer can only print a sequence of the same characters each time. At each turn, the printer can print new characters starting from and adding at any place, and will cover the original existing characters. So let me just explain the description about here. So we are having a printer. We are going to print out the string AAA BBB. So how it gonna print? It can print 6 A's at the same time, and then in between it will, so yeah, this is still A, and then it will cover some A's, and then this areas will become B, so it will be the minimum of 2 times. Yeah, so this is the definition of the description. It means yeah, if you print some letters, so for example AAA, but in between you can also print a B if you want to get a string of ABA. And this is a difficult problem. Yeah, we have to use some examples to explain how can we solve it optimally. So I'm gonna try to follow some examples. So for example, we're gonna print out this like A, B, C, A. Yeah, so for a normal case, if we just want to print out 3 letters A, B, C, if there's no this A at the right side, so how many times? Yeah, if all the characters are different, so it's gonna be the 3 times. So minimum it's gonna be 3 times. But what if at the end there is a character that is also the same as the first character? So it's gonna be 3 times. Yeah, so this seems strange. Yeah, but it is also straightforward because the greedy idea is yeah, so for me, if I just print out a letter A, so why not I just print out all the letters for A's here, and then in between I will covered by a B and C, and I get the same result. Yeah, so the greedy idea is from here, but actually for solving this problem, greedy idea is not enough. We have to use dynamic programming. Yeah, so this is the difficult part, because it includes greedy and it includes dynamic programming. That makes the problem difficult. Yeah, so that is one case. So for the letters, if the first letter equals to the last letter, what is it gonna be? So our definition for my DFS, IJ, is the minimum of typing, minimum of turns for typing the characters from I to J. So for example, from this A to the last A, the DFS will check the minimum time. But what if the first letter equals to the last letter? It is both A's. Yeah, so for this situation, actually, we can minimize the problem from IJ to IJ minus 1. But it will be the same. So this means this DFS equal to DFS I to J minus 1. Yeah, but this is not I minus 1. Why? So this is J minus 1, but this is not I minus 1. Yeah, because there are some testing cases we can prove it. Yeah, because if we have the same character, normally we can save it. We can just save it, because later on we're gonna use this character. Definitely we're gonna count it as 1 time, but we cannot count it as 2 times. So for example, if we have 3 A's, yeah, if for our DFS I to J, if we just count the first and the last character, so it's gonna be DFS I minus 1, and J minus 1 plus 1. Yeah, so this is gonna be the result. But there is still a character A. So for this A, there is another time. So 1 plus 1, it is 2 times. But actually, it is 1 time. So this is why, if we have the same character from the first to the last, so what are we gonna do? So our DFS would become I to J minus 1. We should not count it as 1. We can't count it, because we have the same character. We're gonna count it later. So this is the difficult part. Yeah, and another case is if this character is not A. So for example, if this character it is B. Yeah, now this character is B. What is gonna happen? So this A and this is B. Yeah, so for this situation, we have to use the rinse DP. So the rinse DP idea is from character, we're gonna cut it from the different cases. For example, we're gonna cut it from this A to B, C, B. So for this A, there's one time. What about this B, C, B? As you can see, B and B is the same, so there are 2 times. So 1 plus 2, it is 3. Or we can cut it from here. This AB and this CB. So for this AB, there are 2 times because they are all different. And for this CB, there are 2 times. So 2 plus 2, it is 4 times. But we're going to always check the minimum time. So the minimum is 3. It is cutting from here. Yeah, it is cutting from here. This is going to be the minimum time. Yeah, so this is the final solution. If they are equal, we're going to use this formula. If they are not equal, we're going to cut in between and check the minimum. Now let me go to the code editor to finish the coding. So we're going to use a DFS. So in this DFS, I'm going to put I and j. So the definition of the DFS is from the position from I to j. What is the minimum of preteens? What is the minimum of preteens? So it is 2. So this is the definition. I'm going to prepare a variable n. It will be the length of the string, and I'm going to return I to n minus 1. I'm going to return this I is 0 and j is n minus 1. Now I'm going to finish writing the DFS part. Yeah, but before that I need a cast because this is dynamic programming. And then I'm going to write the main function. So if I equal to j, it means yeah, I have one character. If there's only one character, how many preteens? So I need one. At least I need one time. At least I need one time of printing because I have to print it out. Yeah, if I equal to j. Now I'm gonna check if si equal to sj. So this means if the first character equals to the last character, so I just need to return this I to j minus 1. Yeah, because here I can't use I minus 1, I plus 1 plus 1 as I explained earlier because this is not right, this formula. We cannot plus 1 yet. We have to plus this 1 to the end, to the final return. It's gonna return a 1, but we cannot plus 1. And then we're gonna check the minimum value of all the different splittings. So it's gonna be the minimum of DFS. I'm gonna use a k plus DFS, k plus 1 to j, and for I in range I to j. So the meaning over here, yeah, this is the k. So the meaning of here is just that. Yeah, let me clear it. So the meaning of this line is just that. We're gonna check. So if this is for example, if this is A and this is B, there's some characters in between we don't know. And then we're gonna check the different splittings. We're gonna split one by one. As you can see, this k first starting from I, so this DFS I, it means the first character A. And if this k equals to j minus 1, so j minus 1 plus 1, it is this character B. Yeah, so we're gonna enumerate all the different cases and check the minimum value. So finally we're gonna return this minimum. I just write it in one line for simplicity. So this is the entire code. The code is not so difficult, but it's really difficult to think about this testing case. If you can think about this testing case, yeah, normally you can solve the problem. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and the time complexity is I times j. So the I is from I is n, the length of the string, and j is also n squared. And here is a for loop. This for loop is also n, so it is n cubic. Normally we can guess from the constraints. If it is 100, normally this is a cubic operation, cubic time complexity. So that's all for today. Thank you for watching. See you next time.